In this video, I'm going to cover how to find critical values for a t distribution when you're dealing with confidence level of 99% and 3 different sample sizes. So we can see how the critical value changes based on the sample size. And so I'm going to do this using this t distribution table over here on the left. In this t distribution table, the only orange row that I care about is the bottom orange row. And each one of these values here represents a different confidence level that you're going to be given. And so keep in mind, these are not the only confidence levels that you can see. There are many more. However, these are the standard ones. And so for each of our examples, we have a confidence level of 0.99, which means I only care about this value here, which means I only care about this column. And so the numbers in this column are the possible critical values that I'm going to be pulling out, right? They're the possible values for t sub c. I just need to use the degrees of freedom, which are given by these numbers over here on the left. I need to use the degrees of freedom to find the critical value. So for part A, the degrees of freedom is going to equal n minus 1. And so here degrees of freedom is equal to 4. And so in my t distribution table, I'm going to look at the intersection of degrees of freedom 4 and my confidence level 0.99. And I see that the critical value is given by t sub c equal to 4.604. If I look at part B, the degrees of freedom here is going to be given by 90. And so again, I want to match the degrees of freedom to my table. However, when I look at the table and the degrees of freedom that I'm given, I don't have 90 on this specific table. And so what I need to do is I need to say, okay, so not on table, which means I'm going to be approximating my critical value. And so I'm going to use instead the smaller value that's closest to this degrees of freedom. And so my options would either be 80 or 100, right? Those are the two closest degrees of freedom on this table. And I'm always going to take the one that's smaller. So here, I'm going to say that the degrees of freedom is approximately 80, right? Which normally we wouldn't say that 80 and 90 are approximately, but for the purposes of using this table, we are. And so on the t table, we can see that the critical value is going to be 2.639. Looking at this last example, we have a degrees of freedom equal to 599. However, again, this is not on the table, so we need to use the next smaller value. And so we're going to use 500. So while 1000 is closer to 599, we always want to use the smaller value. And so if we look at the intersection of this row and column, we see a critical value of 2.58.